Download this code from codegive.com, link in the description below. Azure Blob Storage.net Client Request Timeout, a deep dive and troubleshooting guide. Working with Azure Blob Storage in your .NET applications is generally straightforward. However, you might encounter scenarios where requests time out, leading to frustrating errors and negatively impacting your application's performance. This tutorial will delve into the intricacies of Azure Blob Storage.net client request timeouts, exploring common causes, configuration options, troubleshooting techniques, and providing practical code examples. Understanding request timeouts. A request timeout occurs when a client, in this case, your .NET application using the Azure Blob Storage SDK, sends a request to a server, Azure Blob Storage, and doesn't receive a response within a predefined period. This could be due to various factors on either the client side or server side. Why timeouts matter? Application performance. Excessive timeouts degrade user experience, leading to slow loading times and unresponsive applications. Data integrity. Timeouts during write operations, uploads, appends, can result in incomplete or corrupted data. Error handling complexity. Timeouts force you to implement robust error handling and retry logic. Resource wastage. A timeout doesn't necessarily mean the operation failed on the server side. It could be processing, leading to potential duplicated data if retried aggressively without proper idempotency. Common causes of Azure Blob Storage request timeouts. 1. Network connectivity issues. Client side. Poor internet connection, firewall restrictions, proxy server problems, DNS resolution issues. Server side. Azure region outages, transient network glitches within the Azure infrastructure. 2. Large file sizes. Uploading or downloading very large files can take a significant amount of time, potentially exceeding default timeout values. 3. High network latency. The physical distance between your application and the Azure Blob Storage endpoint can introduce latency, especially during uploads/downloads. Also, general internet congestion can contribute. 4. Server-side overload. Azure Blob Storage is a highly scalable service, but it can still experience temporary periods of high load, leading to slower response times. 5. Incorrect timeout configuration. The default timeout settings of the Azure Blob Storage client library might be insufficient for certain operations or network conditions. 6. Client-side processing. Your application might be performing CPU-intensive tasks before or after the request to Blob Storage, delaying the sending of the request or processing of the response. 7. Code errors. Inefficient code, example blocking operations on the main thread, can introduce delays that lead to perceived timeouts. 8. Concurrency issues. Excessive concurrent requests from your application to Blob Storage can overwhelm the network connection or the Blob Storage service, causing timeouts. Configuring request timeouts in the .NET Client SDK. The Azure Blob Storage.net client library provides several ways to configure request timeouts. Blob client options. Retry.delay. Configures the delay between retry attempts. Blob client options. Retry.max. Retries. Defines the maximum number of retry attempts. Blob client options. Retry.mode. Specifies the retry mode, example exponential backoff, fixed interval. Blob client options. Transfer options. Maximum concurrency. Specifies the maximum number of concurrent transfers. Blob client options. Transfer options. Initial transfer size. Specifies the initial transfer size for parallel transfers. Blob client options. Transfer options. Maximum transfer size. Specifies the maximum size for a single transfer, which affects the number of blocks a large blob will be broken into. Asterisk individual operation timeouts, per request basis use blob client options or blob request conditions, deprecated. Here's a detailed explanation with code examples. 1. Setting timeouts globally, for the entire blob service client. This approach configures timeouts for all operations performed by a specific blob service client. This is a good starting point for setting baseline timeout values. Explanation asterisk. Asterisk blob client options asterisk. This class allows you to configure various settings for the blob service client. Here, we're configuring retry settings, including delay, the maximum number of retries, and retry mode. We're also configuring the transfer options to optimize large file uploads. Asterisk retry mode. Exponential asterisk. With exponential backoff, the delay between retries increases exponentially, example 2 seconds, 4 seconds, 8 seconds, which can be more graceful to the server than a fixed delay. Asterisk transfer options asterisk. This section deals with parameters related to multi-part uploads which are used when files are larger than some threshold. Maximum concurrency controls how many concurrent transfers can happen at the same time. Initial transfer size and maximum transfer size control how large each block transfer can be. Choosing the right transfer size can significantly affect the upload speed. Too small and the transfer is inefficient due to many requests, too large and the individual blocks will take longer to transmit, and may time out in unstable networks. Asterisk error handling asterisk. The try-catch block demonstrates how to handle request failed exception, which is the exception type thrown when a blob storage request fails. The EX status property is especially useful for diagnosing the cause of the failure. Status code 408 often indicates a timeout. 2. Setting timeouts per operation, using blob client options for individual calls, or blob request conditions for backward compatibility. Sometimes, you need to fine-tune timeout settings for specific operations. This is especially important when dealing with operations that are known to be potentially long-running. Explanation asterisk. Asterisk. We're creating a blob client options instance specifically for the upload async operation. This allows you to override the global timeout settings, if any, for this particular request. Important note on deprecation asterisk. The blob request conditions class used to be the standard way to specify timeouts and other conditions on individual requests. While it still exists for backward compatibility, the preferred method now is to use blob client options as demonstrated above. If you encounter code that uses blob request conditions, it's recommended to migrate it to the blob client options approach. Troubleshooting request timeouts. If you're experiencing request timeouts with Azure Blob Storage, follow these troubleshooting steps. 1. Check network connectivity asterisk. Asterisk. Verify that your application can reach the internet and that there are no firewall restrictions blocking traffic to Azure Blob Storage endpoints. Asterisk. Use tools like ping or traceroute to diagnose network latency and routing issues. Example: ping your storage account name.blob.core.windows.net. Asterisk. If your application is running on a VM, check the Network Security Group (NSG) rules to ensure that outbound traffic to the internet is allowed. To monitor Azure region status asterisk. Asterisk. Check the Azure status page, https://status.azure.com, to see if there are any known outages or performance issues affecting the Azure region where your blob storage account is located. 3. Increase timeout values asterisk. Asterisk. Experiment with increasing the retry.delay, retry.max retries, and transfer options values in your blob client options or blob request conditions. Start with conservative increases, example double the current values, and gradually increase them until the timeouts are resolved. 4. Optimize large file uploads/downloads ***. Use the upload async and download to async methods of the Blob client class, which are designed for handling large files. These methods automatically split the file into smaller chunks and upload them in parallel. Configure the transfer options. Maximum concurrency, transfer options. Initial transfer size, and transfer options. Maximum transfer size properties in the Blob client options to optimize the performance of parallel uploads and downloads. Experiment with different values to find the optimal settings for your network conditions and file sizes. For very large uploads, consider using the stage block and commit block list methods for more fine-grained control over the upload process. 5. Implement retry logic ***. Wrap your Blob storage operations in try-catch blocks to handle request failed exceptions. Implement a retry policy using the retry options in Blob client options to automatically retry failed requests. Consider using an exponential backoff strategy to avoid overwhelming the server with retries. Implement idempotency in your operations. If a timeout occurs during a write operation, a retry may result in duplicate data if the operation partially succeeded on the first attempt. Design your application to handle this scenario gracefully. 6. Reduce concurrency ***. If your application is making a large number of concurrent requests to Blob storage, try to reduce the concurrency to avoid overwhelming the network or the Blob storage service. Use techniques like throttling or queuing to limit the number of concurrent requests. The maximum concurrency setting helps with this. 7. Profile your code ***. Use a .NET profiler, example Visual Studio Profiler, .race, to identify any performance bottlenecks in your code that might be contributing to the timeouts. Look for long-running synchronous operations, excessive memory allocation, or inefficient algorithms. 8. Check client machine resources ***. Ensure that the machine running your client application has sufficient CPU, memory, and network bandwidth. A resource-constrained client can contribute to perceived timeouts. 9. Consider proximity to Azure region ***. If possible, deploy your application to an Azure region that is geographically close to the Azure Blob storage account. This can reduce network latency and improve performance. 10. Enable logging ***. Enable logging in your Azure Blob storage account and in your .NET application to capture detailed information about the requests and responses. This can help you diagnose the cause of the timeouts. Example, Advanced Retry Logic. Key improvements in the Advanced Retry example ***. Explicit retry loop ***. We implement our own retry loop using a for loop, giving us full control over the retry process. Exponential backoff ***. The delay between retries increases exponentially, using initial delay **math.pow, 2, retry count. Stream reset ***. It's crucial to reset the stream position, stream.seek, 0, seek origin.begin, before each retry. Otherwise, the upload will start from the end of the stream. Exception rethrowing * after the maximum number of retries is reached, the exception is rethrown so that the calling code can handle the failure. Asynchronous delay * the task.delay method is used for asynchronous waiting, preventing the main thread from blocking. Retry options configuration * within the method, Blob client options are used to configure the number of retries to 0 so we don't double retry in addition to the retry logic we built in. Best practices. Connection string security * never hardcode your connection string directly in your code. Store it in a configuration file, environment variable, or Azure Key Vault. Asynchronous operations. Always use the asynchronous methods, upload async, download to async, etc., of the Blob storage client library to avoid blocking the main thread. Cancellation tokens. Use cancellation tokens, cancellation token, to allow users to cancel long-running operations. This is crucial for responsive user interfaces. Idempotency. Design your operations to be idempotent. If a timeout occurs during a write operation, a retry might result in duplicate data if the operation partially succeeded on the first attempt. Monitor performance. Regularly monitor the performance of your Blob storage operations using Azure Monitor or other monitoring tools. This can help you identify and diagnose timeout issues before they impact your users. Test under load. Thoroughly test your application under realistic load conditions to identify potential timeout issues. By understanding the causes of Azure Blob storage request timeouts and implementing the techniques described in this tutorial, you can significantly improve the reliability and performance of your .NET applications that interact with Azure Blob storage. Remember to monitor your application's performance, adjust timeout settings as needed, and implement robust error handling and retry logic to ensure a seamless user experience.